The universe, a vast realm of enigma, has been an ongoing source of discovery as we deploy increasingly powerful telescopes to space, leading us to uncover numerous exoplanets. Among these captivating celestial bodies, Proxima stands out as one of the most intriguing. Scientists, including those affiliated with NASA, have dedicated substantial time to studying this enigmatic planet. What insights have they gained from their investigations? Could life possibly exist on Proxima? Join us on a journey through NASA's exploration of Proxima b, where its secrets are unveiled. Not too long ago, news broke about the revelation of a newfound planet. Named Proxima Centauri b, or simply Proxima b, this exoplanet lies beyond our solar system. Over the past several years, astronomers have discovered a growing number of Earth-sized exoplanets orbiting distant stars. Some of these exoplanets reside within the habitable zones of their respective stars, where conditions might allow for the existence of liquid water on their surfaces. However, the scientific community's excitement surrounding Proxima Centauri b stemmed from the fact that it orbits the star closest to our own Sun, a mere 4.2 light-years away. Proxima b was initially detected by Guillaume Anglada Escudé and a team of astronomers during the Pale Red Dot campaign. Its existence was later confirmed using the High-Accuracy Radial Velocity Planet Searcher (HARPS) spectrograph, mounted on the ESO 3.6-meter telescope. This confirmation relied on a method called Doppler spectroscopy, or the radial velocity method. By observing the spectra of stars for signs of wobble caused by the gravitational pull of planets in orbit, astronomers can infer the mass of these celestial bodies. In the case of Proxima b, astronomers estimated its mass to be between 1.24 and 2.06 times that of Earth. In 2020, the presence of Proxima b was further confirmed using the ESO's Very Large Telescope, VLT, and its Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, ESPRESSO. The transit method, commonly employed in exoplanet discoveries, proved impractical for Proxima Centauri due to its status as a low-mass and less luminous M-type, or red dwarf, star. With a mass approximately 1.17 times that of Earth, Proxima Centauri b closely orbits its star in a mere 11.2 days, in stark contrast to Earth's year-long orbit around our Sun. Despite its proximity, Proxima Centauri b falls within the habitable zone of its red dwarf star. Intriguingly, it receives a comparable amount of solar energy from its star as Earth does from our Sun, suggesting the potential presence of water on its surface. Nevertheless, the intricacies of habitability for exoplanets remain uncertain, as numerous factors such as temperature, composition, atmosphere, water availability, and radiation from the host star come into play. Red dwarfs, like Proxima Centauri, are known to emit flares, making the habitability of exoplanets orbiting such stars even more complex and captivating, as you will discover in this video. When astronomers initially confirmed the existence of Proxima b in 2016, they endeavored to determine whether this exoplanet could harbor life. While it resides within the habitable zone of its star, subsequent studies introduced skepticism regarding the prospect of alien life. Consequently, the question of whether life could exist on Proxima b has remained a divisive topic within the scientific community. However, addressing this question requires further examination of Proxima b's atmosphere, ideally through observations as it transits across its host star. In a recent study supported by NASA, a team of astrophysicists led by the University of Chicago concluded that the likelihood of such observations yielding evidence of an atmosphere on Proxima b is slim. The investigation presenting these discoveries was spearheaded by Emily A. Gilbert, a graduate student affiliated with the University of Chicago's Department of Astronomy and Astrophysics. Collaborating with researchers from the Adler Planetarium, the Center for Space Science and Technology at the University of Maryland, and the Exoplanets and Stellar Astrophysics Laboratory at the NASA Goddard Space Flight Center, Gilbert delved into their study's outcomes. However, even if life were to exist on Proxima b, a significant hurdle looms: the formidable challenge of space weather. For denizens of Earth, the term weather evokes thoughts of the sun, clouds, rain, and wind. If you possess knowledge about atmospheric conditions on other celestial bodies, you might consider those as well. However, space weather diverges from these familiar concepts. It emerges from stars, including our own Sun, permeating the surrounding space. Space weather entails ionizing radiation emitted during stellar flares, such as those occurring on the Sun or other stars. This radiation poses a lethal threat to any lifeforms on distant planets. This danger is particularly pronounced for red dwarf stars, known for their more frequent and volatile flares. Unfortunately, Proxima Centauri, the star of the Proxima system, happens to be a red dwarf star. Astrophysicists at the University of Sydney in Australia utilized radio waves to identify and investigate the space weather encompassing Proxima's vicinity. Our Sun's closest neighbor is known to harbor at least 2 planets. One of them, Proxima Centauri b, shares a mass similar to that of Earth, while the other, Proxima Centauri c, boasts a mass approximately 7 times greater. Notably, Proxima Centauri b orbits within the star's habitable zone, where favorable temperatures may allow for the existence of liquid water on its surface. However, if you anticipate these conditions to signal the presence of life, disappointment awaits. The discovery of flares on stars akin to Proxima suggests a bleak outlook for life within this system's planets. Proxima Centauri b experiences intense bursts of ionizing radiation from its star due to its close proximity to Proxima Centauri. It is crucial to recognize that the presence of an exoplanet within the habitable zone does not guarantee its habitability. This is particularly true for Proxima b. Proxima Centauri, a cool and small red dwarf star, positions its habitable zone remarkably close to the star itself, even closer than Mercury is to our Sun. Research indicates that this proximity exposes the planets to hazardous ionizing radiation, which could potentially render them sterile. While our Sun emits ionized particles during coronal mass ejections, the distance between Earth and the Sun's surface provides some protection from their impact. Additionally, Earth benefits from a robust magnetic field that shields us from these intense solar plasma bursts. By studying the space weather surrounding Proxima Centauri, scientists have inferred that red dwarf stars may not be the most favorable environments for life. However, various factors, such as a planet's distance from the star and the strength of its magnetic field, could influence the situation differently. Some red dwarfs may also exhibit more activity compared to others. Consequently, making generalized statements about red dwarf scenarios proves challenging. In further investigations concerning the potential for life on Proxima b, scientists have attempted to envision how Earth would appear if it orbited Proxima Centauri. They utilized modeling techniques to simulate the conditions. Once again, the concept of habitable zones comes into play. Merely being within the habitable zone, the region where water could exist on a planet's surface, does not guarantee habitability. Other factors, such as the actual presence of water and the ability of an atmosphere to survive in that orbit, must also be considered. Atmospheres are vital for sustaining life as we know it, as they regulate climate, maintain favorable surface pressure for water, shield against hazardous space weather, and provide the necessary building blocks for life's chemistry. In their research, scientists employed computer models that employed Earth's atmosphere, magnetic field, and gravity as proxies for Proxima b. They also calculated the average radiation output of Proxima Centauri based on observations from NASA's Chandra X-ray Observatory. Using these data, the model simulated how the intense radiation and frequent flares from the host star would affect the exoplanet's atmosphere. An active red dwarf star like Proxima Centauri can strip away an atmosphere when high-energy extreme ultraviolet radiation ionizes atmospheric gases, causing the release of electrically charged particles. During this process, the newly formed electrons gain sufficient energy to escape the planet's gravitational pull and flee into space. As negatively charged electrons depart the atmosphere, they create a significant charge separation that drags positively charged ions along, leading them into space. Within Proxima Centauri's habitable zone, Proxima b experiences bouts of extreme ultraviolet radiation hundreds of times more potent than what Earth receives from the Sun. This radiation possesses enough energy to strip away not only the lightest molecules like hydrogen but also heavier elements such as oxygen and nitrogen over time. The model demonstrates that Proxima Centauri's intense radiation depletes an Earth-like atmosphere approximately 10,000 times faster than what occurs on our planet. To understand the potential variations in this process, scientists examine two additional factors that exacerbate atmospheric loss. First, they considered the temperature of the neutral atmosphere, known as the thermosphere. Their findings revealed that as the thermosphere heats up due to increased stellar radiation, atmospheric escape becomes more pronounced. Share your thoughts on the possibility of life existing on Proxima b in the comments section below.